anyway, I was just saying it's very nice to be back here in Tobermory. I'm going to be presenting work that I've been doing for a number of years now in association with the Underwater Archaeology Service at Parks Canada. Of course, there's numerous other individuals. I should mention the site has been a tremendous support with the work we carry out, and obviously we could not do it without them. The title is a bit of a misnomer. We will be taking a closer look at the preservation of the wrecks, but what I'm going to be talking to you about is the monitoring program, and talking to you a bit in general terms, just trying to give you putting it in perspective why we do the work we do and what our goals are. I will be talking about the evolution of the monitoring program, because that's one thing we found is that the program does not remain static. It has to evolve as we do, as the technology evolves, and based on what we have learned about the wrecks. And I also should say that some of you here probably have a lot more experience with the wrecks in Fathom 5 than I do. So I'll try and stick to my thing, which is the preservation. So working out the controls here. A little bit about the history of Parks Canada with monitoring shipwreck sites. We actually have over 25 years monitoring shipwreck sites. We are somewhat pioneers in this field. It all started for us at Red Bay, which many of you know about, and I'm sure Marc-Andre will be talking a lot more about later this afternoon or this evening. But here in the park, we have about 20 years experience monitoring the shipwrecks. And we've done I'm going to use the royal word we a lot here, and I don't mean we in I'm a conservator, as you probably saw in the title slide, but I mean archaeology and all the other support people we've worked alongside of. So Parks is really carrying on work that was already started at the site, but Parks' role was really to focus on and identify and characterize the types of deterioration we were seeing at the shipwrecks at the site. So, as I've said, we've been somewhat pioneers in this field, but it's something that's gathering a lot of steam worldwide. There are now many research groups out there. RAR is one. It's a Swedish group, and that's Reburial Analysis of Archaeological Remains. SASMAT is another. That's Survey, Assess, Stabilize, Monitor, and Preserve, and it's a European-based group. And way out in Australia, we also have the Australian Historic Shipwreck Protection Program. So these are just but a few to mention, but it's something that the last number of years has really caught on. And I don't know if you noticed in the first two groups that I mentioned, they're about reburials. So it's reburying shipwrecks and artifacts submerged. But in Fathom 5, of course, we haven't excavated the wrecks, and we're not going to rebury them. So it's somewhat of the wrecks in Fathom 5 are much like an open-air museum. You can visit them in the context, and the context is a shipwreck. So this is a very unique angle we have here, but it has its challenges in preserving them. And I have to say thanks very much to Andrew for setting the precedent with my cheat notes here, feeling good about I have to say I've been on holiday for a week and I wasn't sure I could wing it all, so I'm doing a combination. It seemed to work for Andrew, so I'm going to attempt it here too. So a little bit about the park and Fathom 5, and why did we start this management or this monitoring campaign? Well, Parks Canada has a management policy that is to respect the legacy and resources within the park boundaries. So in 1991, Fathom 5 management asked for the development and implementation of a submerged cultural resource monitoring program. Actually, I think the statement by the acting chief park warden at the time really summed it up nicely. He called this program a tool for what would provide essential information for better understanding and management of these cultural resources. This is exactly what we're trying to do here. So Fathom 5, as we probably all know here, is extremely popular with recreational divers. We had Stuart share some of the enchantment that many divers feel. So that's basically another reason we're not even thinking about reburying any of the wrecks or materials we find in situ. So there's 30 identified wreck sites in the park, or close to 30. And these have received thousands of visits per year, as you're probably all aware. Tourism is clearly a huge boost to the local economy and to the park's visitation itself. So although hiding it under, I shouldn't say hiding it, but storing it under in a safer condition under sand, which is one approach we can use, is not really a good fit with this park. So our monitoring program here was based on the values of these wreck sites. So the historical and heritage value, the value to the community, and the experience of the site itself. These are all worth preserving. So we had to come up with a rather unique way of endeavoring to preserve the wrecks. So before I talk too much about preservation in situ, so shipwrecks on the lake bed, I just want to mention a bit about raising shipwrecks, because I find when I talk to people, a lot of people think that raising or salvaging wrecks automatically preserves them. Well, this just isn't true. There are a lot of steps that have to be followed after a ship is salvaged from the lake bed. And this includes documentation, cleaning, some sort of preservation treatment, and careful drying. But the story doesn't end there. There's work down the road that must be maintained if these shipwrecks are going to be maintained. So raising does have one obvious advantage. It makes it more accessible to the public. But this is something we're working on at Fathom 5 as well. So the slide you're looking at now is actually under UAS's first field project, and that was actually raising a shipwreck. So I just wanted to point out that we have and we will possibly raise more in the future if we ever get the funding. Maybe Marc-Andre would like to comment on that later. Anyway, so this is the Browns Bay vessel. It's a War of 1812 type gunboat. It is, as I said, field project number 1. It was conserved on site by archaeologists and conservators. And it has been quite the success story. It is in good condition now. And in fact, it was in such good condition a couple of years ago, we actually moved it down the road from Mallorytown Landing, where it was found, and preserved to Prescott, Fort Wellington. And this is part of a 200-year celebration to commemorate the War of 1812. But of course, shipwrecks being on submerged or on land are rather difficult to accommodate. So we had to build a purpose-built display center around it. So you can see the costs keep on piling up. This is 40 years after it was raised. So we do have plenty of examples out there. On the top left, you can see the Chalupa. This is another Parks Canada wreck that was raised in Red Bay. It is a 16th century example. In the middle there, you can see the Mary Rose. This is a Tudor example. So about 1545, I believe, is when it sunk. It was discovered, well, actually twice. Once in the 1800s and then later in I think 1965. But it wasn't until 1982 that they even attempted to raise this. And the conservation is still ongoing, but I hear it's almost through treatment, and in another couple of years it will enter the drying stage. So that kind of gives you a perspective of how difficult it is. I mean, these are very large vessels, but how difficult and what a lot of effort goes into this. However, as there are numerous wrecks around the world, it's been recognized it's very difficult. I mentioned cost, but also the logistics to raise the wrecks. So in 2001, UNESCO made the Convention on the Protection of Underwater Cultural Heritage. I think it wasn't ratified until 2009. But the interesting part in terms of preservation is they actually stated that the preferable and recommended first option for preserving underwater cultural heritage was to preserve it in situ. So that's rather gratifying for us to know here in Fathom 5 that we've been on track for all these years. So another point I just wanted to bring up, and I don't know who this gentleman is, but maybe they're present, is that the effects of raising a shipwreck are felt years after it's raised. Here, many of you have probably noticed it. It's the rudder that was salvaged from the city of Grand Rapids. It's on display at a local museum just down the street. And in the black and white photo, that's it a number of years ago. Don't have an exact date. And then the other image on the right, you'll probably recognize the boofy hair. That's me standing in front of it a couple of years ago. Now, it's in pretty good condition. It's had some supports built. It's had some sort of surface coating on the metal. You can see, even in the black and white photo, it has begun to wear. But it's overall, it's not too bad. However, if you take a closer look at it, you can see signs of deterioration. And the point is, it's always there. Deterioration is going to continue to happen. So and that's why you always have to monitor and sometimes intervene if you're trying to keep artifacts for the long term. So in this picture, I shouldn't say this. I should have looked up what this is. Orange stuff. I think that's lichen, but I know there's a lot of biologists here, so I'm going to call it lichen. My apologies if it's not. You can see the wood has bleached and it's starting to crack. I'm not sure in this photo if you can see the iron staining. So these are all signs of deterioration. It's there. It's not a big threat at present, but it does add up over time. So, oops, I think I'm out of order. That's all right. So, back to looking at shipwrecks. Canada is a very large country. We have lots of water. We have a rich maritime history. So it's not surprising that that much of our cultural heritage is in the water. Well, Parks Canada, as I said at the beginning, has over 25 years involved in the monitoring of some of these sites. We have monitored sites at Red Bay, as I mentioned. That was our premier. Restigouche, Louisbourg, and of course here in Fathom 5. These are shipwreck sites, but I have to say there has been some monitoring on other submerged sites. There's Atherley Narrows near Aurelia, which is an ancient Aboriginal site with fishing weirs. And it's interesting, it was first observed in the modern world, I think by Samuel de Champlain. And he noted it in his journals as he noticed natives at the time using it. And so that was a modern site, but that must have been, it was still in use at that time. So it would be a modern sighting of an ancient site still in use. So interesting. Anyway, we do have a range of sites. We have French frigates, Basque whaling vessels, and North American commercial crafts here in Fathom 5. But what I'm talking about today actually can apply to any of these sites. So the first obvious effect on a vessel is the wrecking event. This is actually the Hansi. It was en route from Sweden to Melbourne, and it unfortunately hit bad weather and came ashore and wrecked along the rocks. It was interesting. Apparently, for 2 weeks after this event, the fishermen in the area did a cracking trade on lumber. so there's that kind of stuff. But this event, I'm really sorry about this swirling and sinking event. Got a little crazy last night and started animating things. The second example, which is zipped across your screen, is another fun shipwreck. Well, fun in my mind. It's the Blue Jack, and it's a very classic example of a boat being stuck fast. Yes, it is stuck on a lighthouse, and it's actually very similar to recent events. The captain actually went below decks in the evening, leaving his first mate in charge, which in retrospect didn't seem to be a very good idea, because even though there was bad weather, the lighthouse was operational and visible from 2 miles. So anyway, that's affected that ship. And for local connection here, whoops, I've just leaned on something. Let me just... This one is, of course, right here from Fathom 5. It's the Avalon Voyager 2. It's a spectacular monument to the Canadian weather. In this slide, I think it was taken some time in the 1980s. This ship, as many of you probably know, had a couple of lives here. Sadly, not as many as a cat, because after first coming aground and some salvage, there was an attempt to remove it, but unfortunately that didn't succeed. Eventually vandals set fire and burnt the hull, and it eventually sunk. But the good news is now it's an attraction in the park. So we have mentioned. But anyway, all these wrecking events, they affect the condition. This sounds obvious, but they affect the condition of the boat going down. So that affects their preservation from that point forward. They're not all, it depends on the event that got them there. So we do have to assess what our starting point is to know what the risks are with their preservation. And I also should note that the wrecking event itself is very significant. Seeing it in sight, it sort of collapses time between the diver or the visitor and the event. So there's that natural connection with history that I think is hard to replicate anywhere else. So as you can tell, I'm sort of, even though I'm a conservator and my job is to preserve objects, I really like that aspect of conserving the idea and what's evocative about these objects. And it doesn't always mean putting them in the best possible preservation environment. So, here we are. It's okay. So there's many factors that affect preservation state. We've gone over the wrecking event. The burial environment is an obvious one. Lake water versus salt water has very different effects on materials. The type of materials itself, wood reacts very differently than, say, iron does, particularly in saline and saltwater environments. And any changes in environment can very rapidly affect the condition of submerged cultural materials. So this is the same for any artifact, whether it's in the ground, submerged, and once excavated, as I began this presentation talking about. So all are very susceptible to change, and it's that often it's the wrecking event and the excavation that cause the greatest change, or potentially cause the greatest change to artifacts. What we're finding, and I'm sort of leaping to the end here, but don't worry, I'll keep on going for a little while longer, or maybe worry, I'll keep on going for a little while longer, is what we're finding through our monitoring is most of these wrecks are in a fairly stable environment, which means they have stabilized to one degree. It doesn't mean that they're not vulnerable, and it doesn't mean that deterioration is not happening. But we've established a very good baseline for understanding what could happen, so we can assess any new risks that may come along. But anyway, I'm jumping ahead here. So all these four factors affect the design of a monitoring program. And the point of the monitoring program is, of course, to come up with some sort of preservation strategy. So Parks Canada has been involved in two main strategies. On the left, you can see the very scenic Red Bay. That's the 16th century Basque whaling site that was just last year made a UNESCO World Heritage Site. It was actually one of the first reburial sites. So that was more like the SASMAT and the RAR projects. And the reburial that was first done there was for the excavated and disassembled timbers of what is believed to be the San Juan. And here's what it looks like now. So it's not quite as scenic as perhaps on the right, where you see the very lovely Sweet Stakes and Big Tub Harbor, but it is a very effective way of preserving those timbers. What's so unique about the reburial is that there was a monitoring ports and samples placed within the mound, so we can periodically inspect them, do some water analysis, some wood analysis, and just check that the conditions within the burial mound are stable. And in fact, they have been for over 25 years now. So obviously, not all places are like Red Bay. Red Bay just doesn't have the dive community wanting to visit. It's not so visible from the surface. So reburial there really wasn't a problem. But in Fathom 5, there was just no option to control the environment by reburial. So it's, but as I said earlier, it has its positives. It's like exhibiting an artifact in a historic building. The whole area becomes context, and seeing the wreck where it is, it turns maybe something that's not so unique in the world into something very, very fascinating. So that's part of the lure, and that's part of what we have to preserve. So, trying to see where I am. So the monitoring program at Fathom 5, what we did is we have close to 30 wreck sites, as I said earlier, but of course it would be very hard to monitor all 30 at the same time. So six wreck sites were chosen. That's the Alice G, the Arabia, the Charles Minch, the Newaygo, the Sweepstakes, and the James King. Now these were specifically chosen because it was believed that this subset really exhibited as many as the characteristics that was seen in the park in terms of location depth, the condition of the wreck at that time, the materials present, the wood, the iron, and the burial environment. So the initial step had to be getting a baseline of how these wrecks were looking at that point. We also had to ID the potential factors. We call these in conservation the agents of deterioration that could lead to further deterioration. So these are things like wave action, biological influences, and human interaction. So once we identified these sites, we had to develop a means of actually monitoring these agents and seeing the damage that they did, or I shouldn't necessarily say damage, the gradual erosion of the artifact of the wrecks. So, for example, I'm going to just show you one of those monitoring stations. I'm going to show you a map showing all the monitoring stations, and then we'll take a closer look at one of those. So we've got a map of the sweepstakes, and you can see all the square blocks with numbers and arrows, and these are pointing to the monitoring stations. At the onset of the program, these were to be monitored either annually or semi-annually, but in reality, it depends on the resources available, and it depends on the station type. So The types of stations we had included cross-hull movement measurement stations, wood erosion, which is the wood sample I'll talk a bit more about later, on the hull of a ship on the top left, and expansion contraction stations, which you see on the lower left, and metal corrosion. The stations were designed to be as straightforward as possible and demand as little time. But of course, this would all mean divers' time. So anything on land is a little more complicated, as you know, underwater. So here's the wood sample station, and what that is basically is a sample of wood that is a modern sample, but is the same species as is found predominantly on the hull. So we're sort of measuring, so we don't have to do any destructive analysis on the shipwreck itself. On the right, you can see what it looks like nearly 20 years later in this case. It's been eroded by wave action, but also by biological deterioration as well. The trouble with these samples is we find that the modern sample blocks, their deterioration rates are actually different than the historic material. So it's really just a guideline. We can assess what's going on, but the deterioration rates may be slightly different. Initially, we had hoped that we could establish tighter deterioration rates from these samples, but the actual frequency which we could sample was not as expected. So we've got a more general terms, but it does establish what's going on and what's acting on it. I should say that at the onset, we actually did some sampling, some core sampling of the hulls, and did a technique called lost wood substance analysis. But the trouble, this gives a really good indication of how much wood has been lost, so you have a really tight idea of the preservation state at the time the core was taken. But obviously we cannot do this too repetitively, because we don't want to turn the hulls into Swiss cheese and determine the monitoring program is the biggest threat to the to the preservation. So we have gained quite a bit of knowledge about what's happening with the shipwrecks. We've also gained quite a bit of knowledge about what makes an effective monitoring program. And I have to say that most of the techniques we've used have provided valuable data, but there are drawbacks too for these physical measuring stations. The one I'm showing you right now is an expansion and contraction station. And of course, it is prone to get damaged. It is out there, open to divers, waves. So sometimes we have to repair these, and that can affect the consistency of our readings. And we have put a lot of work over the years to get the readings very consistently. But you can understand that for a program that has carried on for about 20 years and is perhaps measurements only take place once a year and often by different people, that this is, and I should say not always under ideal conditions, particularly the deeper water sites. This is something that's really difficult to achieve. So our next phase of monitoring, we're trying to focus on some other methods, building on what we already know now, that might help us visualize deterioration in a different way. And I should say, too, that because time is often limited, it was felt that by using monitoring stations to assess these shipwrecks, often the larger picture was perhaps not as studied as in detail as we'd like. And I should mention that worldwide, those people that have been carrying out long-term studies as well have recognized that this is a problem of carrying on reliable monitoring programs. So what the suggestion now is that once you've established and characterized what's going on with your wreck sites, that you find more, you sort of scale the physical measurements down, but you remain flexible that after an event that could affect the preservation, and that could be change in water depth, change in water chemistry because of construction or around the water, that then you up it again. So we always have to be ready to change our approaches. But it's gratifying to know that we're not the only ones having to rearrange our revamp our program. So that's what we've done. We've where you see the X marks on some of the stations, we are not using these stations as much now. So we've tried to simplify it so the physical monitoring of the wrecks will be less, having gained a lot of insight. This was done over the last couple of years here. And so to go over what we've done with the monitoring program, we've reviewed the results we've gathered to date. We find that something also difficult to handle sometimes. When you generate a lot of data, you also need a lot of time to review and really think about what's going on. But it is important to stay on top of that. You also need to evaluate the return on each method employed. So some of these methods were actually intended to be shorter term goals. So we have to be conscious of when that period is over. And so we can focus on other ways of preserving shipwrecks. And we have to decide which methods should be continued. What we found happily while we're revamping the program is there's a lot of newer technologies out there that we may be able to make use of and support the work that has been done. So basically, to put it in pictures for you, we started out with a very large physical toolbox kit, and we pared that down, and now we've got a lighter weight mesh bag toolbox. And we're now looking at visual means. So this is which the UAS has been using over the last number of years. This is actually HD videography. And we're finding for monitoring, if we use it in a systematic, repeatable way, we can use this as a ways to assess change, because deterioration is usually a visible thing. And what's interesting for me is that the design of the monitoring program almost 20 years ago was actually designed because it was trying to get data for something that was visually observed. So there's sort of an irony here that before we couldn't do that, we could only get data for physical means, but now we're starting to be able to use visual means to get data. So that's a step forward. So what are we looking at now? Well, this is one example here, the James King. On the left, you see one of the archaeologists diving on site. I like to think he's taking notes on the preservation state. And on the right, you see the stations there. Actually, I should just make sure I'm on track here. I said I was going to read from this. I didn't. I turned that. So using modern tools, we can actually get 3D images. Now, these are, right now, they're just used, used for visitor experience, for engaging the public, and archaeology is using them too. But it's a really neat tool because using digital SLR, or even point and shoot digital cameras, you can actually create 3D images using proprietary software. And how this works, don't worry, I'm not going to go into a long explanation of this, but basically it identifies common points in multiple images. Then the software calculates the camera position for each point. And from there you get a point cloud created in 3D. And this is based on the offset between the images. And from there, you can get a 3D polygonal mesh, and from there you can overlay photographs. So you have the actual dimensions and the photographic image, and you can do this in 3D. Now, what's really interesting for me is that if you include fixed reference points when you take your images, it allows the software to create a really accurate scale measurement. And so from this, that's where I can start creating data if there's any change. So I can actually, rather than take out a tape measure, I can actually take out software and look at these images if we repeat this over time. The advantage is it's a very inexpensive tool. Some of the equipment we already have, and it's very portable. But the disadvantage is, of course, like land photography, light and focus of the images can affect the images and therefore the accuracy of the images. This technique actually has been used for, I'd say, at least 10 years in land conservation, particularly architectural conservation, but the challenge was making this work underwater. So we'll just look at another example, the LSG. So we have the old still image, which is pretty nice, but in terms of monitoring, it's hard to get much data from it. The data stations. Now, for the LSG, another technique was tested out just this past year. And that's the 3D laser scanning. Parks Canada has been working with 2G Robotics. It's a private company. And they've tested the ability to use these laser scanners underwater. It was quite successful initially in the quarry just outside of Ottawa, where the UAS does their checkout dives. But of course, further from home, the investigator, it wasn't quite so successful. But they did try it up here in Fathom 5 last year, as I said. And the first run, I believe, was on the Scoville. But there was too much silt disturbance and light, sort of like what Andrew was saying about the LiDAR. You get water conditions affect how the tool functions. But they tried it at the LSG at night, and it generated a pretty nice image. So this is the laser scanning. It's getting thousands of images as it does so, and here on the bottom, you can see a laser scanned image, and on the top, just for comparison, it's a photograph. You can actually overlay the photograph on the laser image as well. It is an extremely accurate, detailed tool when it works, but it must be repositioned several times, and there is a significant cost and learning curve to using this kind of tool. So it's one of these tools that are in the development stage, and I think it took about 45 minutes per scan, and I think it took 2 to 3 scans to achieve this image, and about 10 minutes dive time, if my memory serves. So it does have potential, and one nice potential of this method is that it could be used attached to an ROV, so those deeper water sites, which divers don't have much bottom time. You can quickly, you can set the ROV going and obtain a really good image. So here's the 3D image, and I should say this was done by Thierry Boyer, one of the UAS last summer. And this is another similar. It's a photographic technique. It's something that Filippo Ronca and I've just forgotten the name of the company we're working with, and an American company are working to provide good visuals. They're going to be yes, Scott Parker. There's a lot of people involved creating dive cards, which I'll show you in a minute. The difference between the image we just saw by Thierry and this one by the Americans is, if you look at this image, it's actually an artistic impression. So it's very good visually, but it's not actually accurate in terms of visuals. For monitoring terms, this is not so good, but maybe for representational terms, it's a pretty good tool. So not sure where I am in time, but just a quick look at the Arabia. This is a sonar image. It's a deep water site, so tools like photography come in very handy for recording details. So I'll just quickly show you a preview of this is still in work in progress, Phil wanted to wanted to have it shown. This is the type of information, how those images are being used. And what I really wanted to close on saying is that what's really interesting about the monitoring program going forward is that a lot of us are using tools for different purposes. Archaeology is using it for their work, for engaging public, and for the monitoring program. And what I'm finding too, and I have a quote somewhere written by someone who was reviewing one of the herbarial site preservation programs, that she actually pointed out that one thing that's most effective about these open air submerged sites, if you get what I mean, you can, they're in their natural context, you can swim around it, and now you can see images brought back. It adds that context. And by promoting these images and explaining to the public, it engages in the process of deterioration. Seems to be a fascinating thing, and it helps keep the history of these wrecks alive in the minds of the public, much better than if we had just hidden them away. Sure, there is some ongoing damage that may happen, but as we've seen so far, it's at a very slow rate. We are preserving the essential quality of the artifact and ensuring that there's no rapid deterioration of the shipwrecks at the same time. I've got this image of here. It's one of the turboats over the sweepstakes, and the point of showing it here is there's still reason to monitor the situation. Changes in water level, we need to be aware of that, and we need to then take closer measurements just to see that it's remaining stable. So physical measurements and paying attention to the data that's out there is also very important. So I'd like to say thank you to a big thank you apparently to numerous people. A lot of people work directly or indirectly in the preservation of shipwrecks here at Fathom 5, and a great amount of thanks to the site. I mean, they were really, they really initiated it and were sort of cutting edge, as it turns out, in their thinking at the time. So thank you very much.